Welcome to Mr. W's class. Hello everyone. Before we get started, these are our need to knows, or what I like to call prereqs for success: division and conversion. Hello everyone again. Now today we're going to talk about unit rates. So let's talk about what is the definition of a unit rate. Well, the definition is the ratio of two measurements in which the second term is 1. So when we talk about unit rates, we want to understand that a unit rate is very similar to a quotient. Here's the difference. When we're talking about a quotient, we're talking about the same two measurements. For example, if I have 10 apples and 5 baskets, I want to know how many apples goes into every basket. That will be 2 apples per basket. Now notice, I am still talking about apples and apples. When we talk about rates, we're talking about two different measurements. For an example, miles per hour. Or if we're in the grocery store and we see that there's a deal, we may ask ourselves, well, how much does one cost? So in that instance, we're talking about items and cost. Let's get into some examples. Here, for our first example, we see that we have 160 miles in 2 hours. Now, we want to find out how many miles do you go in 1 hour. So, when we talk about unit rates, typically our second term, or the term in the denominator, we want to make that 1. So we can write that as follows. How many miles can we go in 1 hour? So there's a few ways to do this. We can really just divide and that will give us our answer. Remember, as I said, it is the same as a quotient. You find a quotient because it is the answer to a division problem, whereas the unit rate is the answer to a rate problem. So let's just divide. 160 divided by 2. Put that down. So we know that if we go 160 miles in 2 hours, if we're going at a constant rate, then we will go 80 miles in 1 hour. Let's take a look at our second example. 4 items cost $18. How much is 1 item? Well, they are telling us that they want the cost and 1 item. The cost per 1 item. So with that, they've already given us what they want us to put in the denominator, because they want us to tell them for every 1 item how much is the cost. So what we can do is put 18 over 4. Why do we put 18 over 4 and divide that? Well, it's very simple. We want to follow the units. They are telling us the cost for every 1 item. Then we want to divide here. 4 goes into 18 4 times. That is 16. Subtract that. We have to introduce some decimals here. So we know every 1 item costs $4.50. Now let's talk about the constant of proportionality. What is the constant of proportionality? Well, That is the constant value of the ratio of two proportional quantities, x and y, usually written y equals kx, where k is the factor of proportionality or the constant of proportionality. Now, the constant of proportionality is given to you on a graph. It is the same as finding the quotient for two similar units, which is the same as finding the unit rate for a rate, and understand that the rate has two different units. That is the only difference. The constant of proportionality, we do the exact same thing. The constant of proportionality is just given to us on a graph. That is the only difference. Okay? So I know there's a lot of words in the definition, so I want to break those down so that you are not confused. When we are talking about a graph, the slope-intercept form is written as y equals kx, where k is the slope. Now, the slope can be the constant of proportionality, but it doesn't have to be. I'll speak about that in just a moment. We will dig into that in our example. Our example here is talking about the hours and the total cost. Now, this could be the amount of hours you work and how much you get paid, or it could be the total cost to rent something, or I will allow you to put whatever scenario that you want. Okay? Now, there is a very easy way to find out what our constant of proportionality is. The easiest way to find out what our constant of proportionality is that we look on the x-axis, which goes horizontally. As you see here, that is the x-axis. It goes from left to right. And then we want to go to 1. If we go to 1 right here and we go up, wherever we meet the y, that will be our constant of proportionality. So we see here that when x is 1, y is 12. So notice that k is y over x. That's very, very important. Remember that k is y over x. So when x is equal to 1, what is y? Y is 12. And that is our constant of proportionality, 12 over 1. Now, as I said before, the k doesn't have to be the constant of proportionality. It can be a slope. So you may even see k written as we see here, we go to 4. And when x is 4, y is 48. K can be 48 over 4 or any other proportion. Okay? But notice, if you find k and k is the slope, you can always reduce k down to find the constant of proportionality. How do we do that? We could just simply divide. And once you do that, you will see here that you will get 12. But notice, any constant, we could put that over 1 and it will be the same thing. So as you see here, k can be 48 over 4, which is proportionate to the constant of proportionality. Okay? The constant of proportionality must be over 1. That's why we make the x 1. We go to that. We go up wherever we hit the line. We look at what y is, and that is our constant of proportionality. Just a little added information on this. To find out if a line is proportionate, there are two things that needs to happen. Number one, the line needs to be straight. And two, it needs to go through 0, 0, which is the origin. If you have a straight line and it goes through the origin, that line is proportionate. And if you want to find what the constant of proportionality is, you go to the x-axis, you go to 1, whatever x is at 1, you go up wherever you hit that line, you look at what y is at that time, you put y over x, and we know x is 1. That is your constant of proportionality. And there you have it, guys. Unit rates and COP, or constant of proportionality. Well, alright, Mathletes, that is all for this video. Thanks for watching. I truly hope it was a help. Don't forget to subscribe, hit the like button, and leave a positive comment below.